Hey, this is Nick, and welcome to another tutorial. Today we're going to be talking about how to create web-based dApps. So this tutorial is actually a part of the Ontology Learning Center that you can find this and other tutorials at learn.towerbuilders.org. So what is a dApp? A dApp is basically a website that interacts with the Ontology blockchain. So in order to start talking with the Ontology blockchain, you're going to want to use something called a dApI provider. So what a dApI provider is it's an existing third-party wallet that lets users manage their assets securely, and it provides an open protocol for you to interact with their wallet. So anytime you want to make a call to the Ontology blockchain, instead of having to form the transactions and the calls yourself, you can just use the simplified API via a NPM package or directly injecting the JavaScript into your application, and you can call these methods provided, and it'll do all the heavy lifting for interacting with the user and making sure that they understand what the transaction is that they're signing and broadcasting it to the network. So let's take a look at the high-level overview of how these interactions take place. So when the user goes to your dApp, they're also going to have a wallet provider open in the background, such as O3 or Cyano Wallet. And what this is going to do is when your dApp is opened in a web browser, it is going to communicate with the wallet provider via this NPM package. And anytime you need to read data from the Ontology blockchain, or you need to sign a transaction and get the user's approval to be broadcast to the blockchain, you're going to interact with this API, and it's going to take care of all the heavy lifting for you. So in this diagram, the user will go to your dApp, and when your dApp starts to load, it's going to call functions on the dApI, possibly to get information about who the user is, or balance information or block times, etc. And all that information will be returned back to you via methods on the dApI. So the benefit of using this over programming your own wallet into your application is that users can feel more secure when using your app because they don't need to paste their private keys into the browser. They can feel confident using your application because they'll be notified and asked for approval by a trusted wallet anytime that your application needs to have something signed by them. Also, on the application development side, it means that it frees up a lot of resources because there's not that initial requirement to build out the transaction signing and the wallet management and where to store the private keys, etc. Because there's a lot of work involved in managing a user's wallet securely, it makes sense to use the dApI instead. So you don't need to have that code in your application and worry about the security implications of storing the person's private key in the website, or on your server for that matter. So let's start by looking at some of the available wallet providers out in the ecosystem today. There are two main ones. They're going to be Cyano Wallet and the O3 desktop wallet. We're going to go over briefly some of the features of each wallet and which one we're going to use for the purposes of this tutorial. First is the Cyano Wallet. This wallet is a Chrome extension that will interact with your website anytime that a user is accessing it from the Chrome browser. A lot of users like this wallet because it's very feature light and its interface is very simple and minimalistic. The user's private keys are stored in the Chrome extension storage, and it allows the user to only focus on interacting with your website via this Chrome extension. The O3 desktop wallet, on the other hand, is a full-featured desktop application. So the user will install the native application onto their desktop and will have it running in the background. So this works on Windows, OS X, and Linux. And it has a very clean interface as well, and it's more of a full-featured wallet as opposed to Cyano, which is a very light wallet. This means that there are a lot of different features and conveniences in the wallet that you may not find in other wallets. And this wallet also interfaces with the Neo blockchain, so you have exposure to a broader audience of users. And also, because it's a desktop application and not a Chrome extension, it allows you to have your website hosted in any available browser on the desktop. So whether it be Chrome, Firefox, Brave, Safari, Edge, or Opera, the user can open your website in any of those browsers and still be able to communicate with their wallet as long as it's open in the background on their desktop. The O3 desktop wallet also has other features, like it has dedicated documentation. It also has a full-featured testbed website that allows you to interact with the dApI from a GUI. So when you're learning how to use the different methods, you can go ahead and test them from the testbed without having to program them into your app yourself before you even know what they do. So for the purposes of this tutorial, we're going to go ahead and use the O3 desktop wallet because it has better developer tooling that's going to help us to explain what the different methods on the dAPI do. And as a dApp developer, it's going to be a great first package for you to integrate because it has broad support for different browsers and it has a larger user base. So when you first get your application out there, you'll have as much support for end users as possible. So if you don't already have this wallet installed, I'd suggest clicking the download link and installing the desktop wallet. And make sure that you have your wallets imported or create a new wallet so that you're ready to move forward with the next step. So now that you're all set up with the dAPI provider, let's go over how to actually install these packages into your application. So these packages are JavaScript packages, and they can be included into your application either via CDN or npm install. So here you can see that we've added script tags that allow you to pull down these packages from the CDN. This specific group of packages is for the O3 dAPI. So because it has a plugin style that supports multiple blockchains and wrapper packages, you're going to install these packages separately. So you're going to need one for the core messaging API and one for the ontology specific methods. When you include these scripts, they're going to be included onto the window at O3 dAPI and O3 dAPI ONT. And to initialize this, you're going to call the init plugins method and pass in the array with the single plugin. And for npm, you can simply do an npm install or a yarn add to add these two packages to your repository. Once you have the packages installed, it's as simple as importing or requiring these packages into your code base and initializing the plugin the same way that we did for the CDN imported packages. So let's now go over the dAPI testbed. What this is it's actually a testbed dApp that can also be used as sample code to reference when you're implementing these functions into your own website. So when you want to access this testbed, it's available at ONT-DAPI testbed.o3.app. So when you access this website, you're going to want to have your O3 desktop wallet running in the background so that the dAPI package in your website can properly communicate with the provider. So on the left-hand side of the testbed, we have our different functions available, and this is going to be the place where you're going to be interacting as if you were calling these methods. And here on the left side of the testbed is the output. Anytime you call any of these methods, whether it be a read method or write method, that JSON output is going to be displayed here. So one of the first functions that you're going to be calling when interacting with the dAPI is getAccount. What this is going to do is anytime you want the user to identify their address to the website, you're going to call getAccount, and it's going to prompt the user in a notification window to select which of their saved wallets they want to expose to your website. And this can be used, for example, when you want to get started with the user and get some information about their account, whether it be the token balances or the status of their account in your smart contract. And so in this notification window, they're going to simply click the drop down, select the wallet that they want to connect with your dApp, and click the connect button. You can see here in the next screenshot that the output is going to be their address and a label that they've given their account within the wallet. So you can use this to help the user to identify which account they have connected to your dApp using this label. So let's now take a look at what the code for this interaction looks like. So on the dAPI, all of the methods are wrapped in promises. So anytime you call a method, it'll return a promise in which you can use the then and catch statements to asynchronously interact with the wallet provider. So when you call getAccount, in the resolve of the promise that's returned, it'll return an argument of an account type. That account type is going to have that JSON object that we just looked at in the output in the testbed that has the address and the label. And so once you have the address and the label, you can use these in the next part of your application. And also note that for all the methods on the dAPI, the rejection of the promise will return a very similar object that has a type, description, and any additional data about that error. So you can use this test code here to get started with connecting the user's account to your application. And if you want to reference the code from this testbed for how to get account, you can actually click on this link and it'll take you to the open source code for that testbed. So now that you have the account address, you're probably going to want to check what the balances are for this account. So for that, we have a method called getBalance. GetBalance is going to work very similar to getAccount in the sense that you call it, it returns a promise, and in the resolve of that promise, you'll get a balance object. But the difference is that it doesn't really require the user to give you any permission for this because you are specifying the address that you want to get the balance for. So it doesn't necessarily have to be the balances for the address that's connected to your application. You can really call this method with an input of any address and get back the ONT and ONG balances for that account. So in the testbed, you can scroll down to the Get Balance section here. You can input an address and click Get Balance. And here on the right hand side, you can see it's a JSON object that has two keys. One is ONT and one is ONG. And it'll have the pre-formatted values for the balance of this account. So let's take a look at what the code looks like for making this interaction. So when you're calling this method, it's going to be in the ONT namespace, in the asset subnamespace, and it's going to be called getBalance. And it's going to take an object as its input parameter with the keys network and address. And so one thing to note about the methods on the dAPI is they're all formatted in this way so that any input parameters will be embedded into an object and passed as a single argument. So this way the ordering of your arguments doesn't matter, and if there's optional arguments, you can simply omit them and not have to put nulls into the arguments that are optional. And so for this specific instance, you can put in mainnet because we want to query the balance for this address on the mainnet. You can paste in any address, and when you call it, it'll again return a promise where the resolve will have a balance object returned. And as you can see here, it's very similar to what we looked at in the output section of the testbed, where the balance object has a value of ONT and ONG returned. And in the catch statement, we have the same error object with the type, description, and additional data. So now that you know how to fetch the balances and get the identity of the user, let's take a look at how to send assets from this user's account to any other account. So for this, we have a method called send. What the send method is going to do is it's going to prompt the user for a signature on a transaction and broadcast that transaction to the Ontology network. So how this differs from something like getAccount or getBalance is that this is actually going to send a transaction to the blockchain that's going to be included in the next block. And because of this, it's going to require that the user signs the transaction with their private key. And so for this type of interaction, it's very important that the user understands what they're signing and how it's going to be broadcast. So let's take a look at how this method works in the testbed. So if you scroll down to the send section, you can see that the main parameters in this are going to be the to address, what asset you'd like to send, and the amount that you'd like to send. So by filling in these three basic parameters in the testbed, we can just click send. And what's going to happen is a notification window is going to pop up. So in this notification window, it's going to inform the user about what application is calling it. Further down in the notification window, it's going to show what assets are being requested to be sent. And it's going to summarize that it's going to be sending from this address that they have connected to your application and the to address that you've specified. So here the user can choose to reject or approve the transaction, and upon clicking approve, what it's going to do is it's going to use their private key to sign the transaction, broadcast that transaction to the Ontology network to be included in the next block, and then return the transaction ID back to your application so that you can have the transaction ID to verify whether or not it's successfully been included in the next block. So let's take a more detailed look at what the code for this looks like. So when you want to call send, it's going to be again in the ONT namespace under the asset subnamespace, and the method is going to be called send. And again, this takes a single parameter, which is going to be in the form of an object that has multiple attributes. So for the send, in this example, we're going to have a network, the from address, which is going to be the address that you got returned from getAccount, and the to address, which is the address that you would like the assets to be sent to. So for example, if you're accepting donations, this is going to be your address that you're going to be accepting the donations at. The asset is going to be either ONG or ONT, whichever one you would like to accept. And the amount is going to be formatted as a string, and in this case it's going to be the same 0.01 ONG that we sent from the testbed. So when you call this function, it's again going to return a promise, and it'll resolve into the then statement when the user has approved and broadcast the transaction, and in the case where they rejected it, it'll fall into the catch statement here. And let's go over this a little more in detail. So you can see here that we have this type called cancelled. So when the user rejects your transaction, it'll hit the catch statement with the type cancelled, and it'll help you to understand that the user decided to reject the transaction that you proposed, and not that there was a network or some other failure. However, upon successful broadcast of the transaction, you can see here that we have the TXID on a return object and the node URL. This is important because if you want to query later on whether or not that transaction was accepted, you can query this node if it's very immediate, or you can query other nodes at some other point in time. So again, if you want to take a look at this code from the testbed, you can actually click here to go to the open source GitHub repo for that testbed. So to summarize, in this tutorial we briefly went over how the interactions will work between your application, the end user, the wallet provider, and the Ontology blockchain, how to communicate with the wallet provider via the dAPI, and some of the methods that are available, which were getAccount, which allows you to let the user identify an account to your application, getBalance, which allows you to query balances for a given address on the Ontology blockchain for their ONT and ONG balances, and the send method, which allows you to request from the user to send assets from their account to another account. I hope you guys found this helpful. Again, if you want to check out this tutorial or any other tutorials, you can head over to the Ontology Learning Center by Tower Builders at learn.towerbuilders.org.